Alright, hi everyone. Let's continue with our data structures and algorithm series. In our today's video, we are going to see another common problem solving pattern, that is sliding window. Let's try to understand how this pattern will help us in solving questions with better time and space complexity. So basically in this pattern, we need to create a window which will, based on some certain conditions, can increase or decrease its size. And it will also move from one position to another position, like moving from beginning to end or in any possible direction. In this way, it will help us in getting our desired output. Let's try to understand this with a simple example. As you can see, I am having a string here called sliding, and the problem statement is find longest substring that has unique characters only. Now let's try to find out the unique characters in this string. I will create a window and my first letter will be S here. Now let's increase the size of our window and let's try to add our next character in this. The next character is L. So now my window size is increasing and I have two characters, both are unique. I will add the third letter, that is I, and that is also unique. The next letter is D here, which is also unique in my window. But the next letter is I now, which is repeating and not unique anymore. So I can say my first substring that is longest is SLID, that has 4 characters. Now we can move this window as well. This time I will start with L and the window will go something like L, I, D, but again we have I which is repeating, so it doesn't help. We will move our window and then we will start with I here. We will add I, D, but again we got I, which is not helpful. But now if I start my window from D, then D, I and G, all 4 characters are unique and this is our desired output. So we can say we have two longest substrings in this string, that is SLID and DING. That's how sliding window helps us in getting our desired output. This pattern is really helpful when we have set of data like array and string, and we are looking for a subset of that data that is continuous in some way. Like in this example, we saw the longest substring is actually a collection of continuous characters. Alright, now we have already got some idea what sliding window is and how it works. Now let's try to look at another example to understand it more deeply. So our question is, write a function called maxSubArraySum which accepts an array of integers and a number called n. The function should calculate the maximum sum of n consecutive elements in the array. So what exactly we need to do is, we have given an array of integers and we need to find out the sum of n consecutive integers. N is already given, like in this example we can see we have an array and we need to find out the sum of two integers that has a maximum sum. If I look at this array, the consecutive numbers that has maximum sum is 2 and 8, that is 10. Remember, the integers needs to be consecutive. In our next example, if we see, we need to find out the maximum sum of one integer here, and that is 6. In the next example, if we see, we need to find out the sum of 3 consecutive integers. If I am not wrong, that will be 8, 5 and 6, which is 19. Alright, now let's try to see how sliding window will solve this problem visually, and then we will write code for it. I will be using my third example and we need to find out 3 consecutive integers that has maximum sum. Let's see it visually. Alright, as we know, we need to find out 3 consecutive integers that has maximum sum. So my window size will be fixed here and that will be 3. My first window will be 2, 6 and 9. That has sum of 17. Now we need to move our window and find out the sum of next 3 consecutive integers. Now as we already have the sum of these 3 integers, what we can do is we can subtract our first element from the sum and then add the next element, which will be something like 17 minus 2, which means we are removing 2 from our window and adding the next element, which is again 2, so the sum will remain 17. Now we need to keep on moving our window to find the desired output. So this time we will subtract 6 from our sum, which will be 17 minus 6, and then we will add new element in our window, that will be 1, and their total will be 12 here. We need to keep on repeating this process until we get to the last element. Every time what we need to do is we need to subtract the first element from the sum, because we already have calculated it, right? So we need to remove this first element from the sum and add the new element. It will basically move our window to the end, and in this way we will be able to find out the maximum sum of three consecutive integers, which will be 19 here, right? So that's how sliding window works. Now let's try to write code and see how we can do it in JavaScript. For that, let's jump to Code Sandbox. Alright, so let's define our first step. Our first step will be to find out the sum of n consecutive integers, and we will consider it as our first window. So I will just write it down. Find sum of first n consecutive integers, right? For that I will start a for loop. For let I equals 0, I smaller than array, not array, actually it will be n, right? And then I plus plus. Now we need a variable where we will store this sum. I will define here let max sum equals 0, and now we will do max sum plus equals array I. Now this will give us the sum of our first window. If I show you visually, it will look something like this. The first window 2, 6, 9, and their sum will be 17. I will just write it down here. It will have 2, 6 and 9, that will be 17. Now this is our first window. Now remember, our steps will be repeating, and the steps were always minus the first element and add a new element into our sum so that we can move our window. Now let's try to write code for this step. So what we need to do is we will keep this maximum sum in a temporary variable. So I will say temp sum is equals to max sum. Now since we are going to repeat our step of subtracting and adding, we will need a loop here. Let I equals n, and then I should be smaller than array dot length should be dot, and then I plus plus, right? Now what we will do is we will use our temp sum equals temp sum. Now remember, we need to subtract the first element of the window array, that will be like I minus n, and then we need to add the new element, that will be array I, right? I'll just write it down how it will look. Now remember, our first window was having 2, 6 and 9. We will be subtracting 2 from this window, that will be 17 minus 2, and then we will be adding the next element. The next element is here 2, right? So we will be adding the next element. Now the benefit is we are using the already calculated value here, right? We don't need to add these two again, which is saving our operations, right? It will improve our time complexity. The next thing we need to do is we need to update our max sum. For that I will use math.max. Now we will just put our temp sum, which is the new sum here, compare it with our old sum and find out which one is better. or which one is greater. I'll just write it down here, comparing old sum with new sum. And once we complete this process, we can say we have found out the maximum sum of our consecutive integers, and that is our max sum. Oops, I just saw I misspelled the length here. It should be length. Alright, now let's try to run this and see if we are getting our desired output or not. For that, I will open my preview tab, open the console, and see we are getting 19 here, which is expected, right? We can test this with our first example as well. So I will just copy this array, will paste it here. In case of 3 consecutive, it will give me 15. But if we go with 2 here, it's giving me 10, which is same as our slide, right? 10. So that's how sliding window works, and that's how it will improve our time complexity and space complexity. Thanks for watching.